Right. Thanks a lot, Lena. Hi, everybody, wherever you are, whatever part of the world. So, what I am going to be covering later next week is primarily the convergence of blockchain and AI. And as much as these two things look very disparate, they are actually connected at several levels. And the workshop is primarily going to explore areas where it is already being used in convergence, and then certain frameworks which we can use in our businesses to assess if a combination of blockchain and AI is suitable for solving certain use cases. So that being said, let me quickly move on because, and as I was telling at the beginning of this chat with Lena, was that this is the longest presentation. Obviously, I'm not going to get into the details here. I'm just going to give an overview. But of course, I mean, we'll have questions at the end. So happy to answer them. And of course, we will cover these things at length when we do the actual presentation. So I think Lena mentioned already about me, things that I do. So just to give you an idea, obviously undergrad and, went to Stanford and then been running this company for the past 8 years now. And I also co-founded a company which is a crypto exchange based out of Estonia and Hong Kong. And that went operational last year. So that again is a very interesting project for those of you who are in the Bitcoin and crypto and all of that space. So that's a very interesting area to look at. Um, so high level, what is blockchain? Convergence of blockchain and AI. But again, once you unpack blockchain, there are different areas, which of course I'm going to be talking about. And then the use cases of the intersection of blockchain and AI. So again, where is blockchain being used today? What are the typical areas you can think of? This is just a very small sample of areas where blockchain is being used, right? And so this is sort of a reference of blockchain and AI put side by side. And as you can see, this is a slightly old data. So I think by the time we have the presentation, I'm going to update this. I'm pretty sure that this number already is very high, right? So I think if you look at Bitcoin alone, this is a little less than $1 trillion at this point, right? The last I saw was 880 or 90 billion dollars market cap, right? So, and then you have all the interesting use cases in supply chain and whatnot. So definitely that value is much higher. And so if you compare that value with these numbers here for artificial intelligence, it almost dwarfs, right, in terms of the value that is being generated and people are transacting almost on a daily basis. It's almost mind boggling. So that's a very different area. Of course, we will talk more about it. Then what basically is blockchain, right? What comprises, what is the core components of the technology. So at a very high level, obviously it's a database. It's a store of data in a very specific format that is write only. It cannot be edited. And there are only few people in the network who have the ability to basically let me see if there's any question. Yeah, there is. Okay, that's a general one there. Okay, and then how the information comes together, like what is a block and what is a chain in the blockchain and how the things are chained together. And of course, they are chained cryptographically. That's another thing which we will be touching base upon. And then the contrast between a centralized network, which is, for instance, any major corporation, Facebook, Amazon, Google, you think of that, it's structured in a very centralized way. And when you contrast that with the peer-to-peer network, which is what blockchain is, how the two are different. And what are the pros and cons? What is the philosophical difference of one data base to the other? And this is actually the nuts and bolts of, looks a very simple slide, but you almost spend like 10-15 minutes going through each of the activities that's happening here, and it gives a very clear picture of what blockchain is, how data is stored, and then why it is immutable and hack proof, right? So all these things which you hear, all the buzzwords, immutable, hack proof, you see this whole idea of mining, your consensus, like everything gets clarified from the slide. So we'll be talking more about that in the presentation. Then let's move on. This is basically how a block structure looks like. You have the Merkle tree, you have the various hashes, you have the non. So I think we'll talk more about that as well. So this is just one kind of block structure, which is the proof of work. Then there is obviously proof of stake and so many other versions now. Then interestingly, if you look at the various components of blockchain, so as the slide says, key constructs of blockchain: distributed ledger, smart contracts, cryptography, network consensus, and game theory. So if you look at all these things as standalone, as principles or as things in practice, they have been there for a very long time. For instance, game theory, obviously, we all know John Nash, he won the Nobel for this in 1994 or 1993, perhaps, for all his work in game theory, which he did in 1960s and 70s, right? And likewise, distributed shared ledger, smart contracts, cryptography going back to World War II onwards, and network consensus. So these ideas have been there and in some form or fashion. What blockchain does is brings these things together in a very unique way, which is what differentiates it from the rest of the structures that are out there and makes it so powerful. And we're going to talk more about that in the presentation. Again, kinds of cryptography, how the two are different, how do you sign, how do you basically check the hashes. We will get into all the details. And then the variety of consensus. We saw network consensus here, then talked about proof of work, then we as I mentioned, there's proof of stake, and a whole host of them, fault tolerant consensus mechanisms. We'll get into the history of the whole evolution of blockchain, how things came about, what is the trigger point, and to where it is today. I mean, we will definitely touch base on that. Then let's look at the evolution of the technology. And this is basically when Bitcoin came together. This is 2009 and 10. Then you had the first Ethereum based versions, which is here, and then the whole sort of ecosystem exploded. Very interesting illustration as to how blockchain comes together. And maybe if I can just spare a moment here, you can see there are all these multiple transactions between all these various actors in any business transaction. So here goods are probably moving from point A to point B, and there are bank records, there are auditors, insurers, everything else for a very simple truck moving from one factory to the other delivering goods, right? And there are all these different transactions. Whereas when you're on a blockchain, you don't have this crisscross. There is just one single piece of truth, and everybody has a copy of the same truth, right? So we'll talk more about that. Some of the buzzwords, but why these buzzwords are so powerful and how they come together, we will talk more about that. Pseudo-anonymous, transparent, hack-proof, provenance tracking, etc. So let's, this is where it gets really interesting. One is obviously the public side of things, which is what things like Bitcoin and Ethereum are, and then you have the hyperledgers of the world, which are more closed network, and how the two are different and why the real need for the two, right? Why do businesses prefer a more closed network, which is why a private blockchain is also getting evolved. And then, of course, a public blockchain system such as the Bitcoin and Ethereum are gaining such major prominence that all the institutional investors, I mean, obviously, you've been following the news, and Tesla and Apple and a lot of major financial institutions are looking to invest in some of the other ways. As for the latest reports, I think I don't think there's any S&P 500 company out there which is not looking at some kind of exposure to crypto. So that is a quantum shift from what was the situation just a year ago, right? So there's a huge transformations happening as we speak. So obviously it's important to take notice why this is happening. Then we talk more about public and private. What is the difference, right? Why enterprises look at it. So we'll get into all these details. Then this entire technology built up, right? The trusted nodes, the kind of consensus, and why they are needed, and how they actually contribute to the ecosystem. Some of the popular ones, the difference between them. And this is how the landscape is evolving. And again, we will talk more about it, and then some of the early adoptions and use cases. So after that, obviously, we will come to the interesting bit, which is obviously the combination of blockchain and AI, right? So when do we need a blockchain? These are some of the areas when you would need blockchain. So if you see multiple parties sharing data, or they're updating it, or there's time sensitive information which is interaction which is there between multiple parties. So these are some of the areas where you would most likely consider blockchain, and these are the benefits you would get. Now if you move on, in current world, again, this is talking more about the AI, how AI is structured, right? Excuse me. So how nonlinear problems are obviously looking to get addressed through some of the powerful AI mechanisms, right, or the tools and processes out there. So it talks about some of the areas where it is already being used very successfully, and how this is being used. And then we talk about areas where AI is going to be getting impacted by blockchain. So this is again still talking about the current state, right, and how these areas come together. So for instance, it is obviously measuring or looking at the outcome and the probability of the outcome, right? And as we spoke about blockchain is more of deterministic nature, right? AI is more probabilistic, whereas blockchain is more deterministic. So that is how the two come together, and I'll just show you in a bit how the two come together, right? So they are two opposite extremes, as I said, but these are the areas where actually the two are being used very extensively. One is explaining AI to itself, right? So making AI more explainable. So the decisions being made by AI, how you can actually decipher those decisions, right? So go back, look at the data sets which contributed to a specific outcome, because now with blockchain you can actually track and trace every single bit of data, whereas when you're looking at AI more or less very high level, you're looking at large chunks of data sets, and you're trying to look at good quality of data, and from that you're hoping that your models become closer and closer to that tight probability range, right? So this is where blockchain comes in and helps you understand what AI is doing and why it is doing, right? So that's one thing. And then obviously this whole concept of decentralized computing. As I said, all this computing today on AI obviously is being done through some of these large firms, Google, Apple, those large firms. And the reason why they're able to do it is because they have all this data on us, and they are able to therefore run those algorithms and come up with outcomes which are obviously personalized to us. But for doing that, they need chunks of data from us on a continuous basis. What blockchain does, it basically breaks down, because information or data is getting generated at a very local level, which means our smart watches, our smartphones, or smart anything which is around us is where all this data is getting generated. And so instead of feeding that data to some big server on Google and then Google telling us what is right, perhaps we can do it on our own local devices, because now our local devices are smart enough to use that data, because you are using blockchain. Therefore, you don't need those reams of data. You just need specific data sets which are actually contributing to the final outcome. So, I mean, it's a very interesting and evolving area of federated learning model, which obviously Google tried in the past, they still do, but overlaying that with blockchain and taking it to the next level. So that is something which is obviously happening as we speak. So obviously blockchain is there for AI, and likewise, AI is also helping blockchain. There are a number of areas where this is happening. So just to check on time, Lena, am I still okay? I have a few more minutes, or this is time for me to stop?
No, you can carry on because we don't have any questions as of now. You can take some time, no problem.
Okay, perfect. Okay. And then obviously how these ecosystems are being built, like especially with blockchain and AI coming together, so obviously improved. And we will get into a lot of details here. I don't want to sort of take the thunder away, if I can put it that way, right now. But there are a lot of these emerging areas where it is already being used in very powerful ways without us knowing it. Uh, let me see if there's any interesting one which I can talk about. Um, so let me quickly just touch base on this audits and compliances. So as you know, the entire audits business is dependent on looking back at every single aspect of data, what has happened, and then try to make sure that it complies with the regulations. So that's at a very high level what happens in audit. Now, with blockchain, because you have this complete traceability end to end, this whole idea of auditing something just basically goes away. I'm not saying auditors are not going to be required, or audit firms like KPMG are not going to be required, but a lot of this task where this information comes together and you have to go and tally and make sure it was all matching, that is now being done by the blockchain protocols. So you don't really have to go back and check. What obviously the auditors are going to be doing, they will be coming up with sophisticated models and looking at various scenarios which are obviously not put in the standard set of data. So blockchain is going to help you make sure that this traceability is there and accountability, auditability is there, and the auditors are going to then augment it by adding their side of intelligence when they are looking externally, looking at various market forces, and then devising things which obviously are not there in the ecosystem as we speak. So that is where the combination is going to come together, where a lot of aspects of what auditors or others, I mean, law firms and so many other professions are going to be taken care by blockchain. That is how things are already evolving. So that's one. Let's look at other areas. So I was talking about the federated learning model earlier on. This is a very interesting concept where I say, democratize AI. Obviously, there are four firms in the US, Google, Apple, Facebook, Microsoft, and then Tencent's Baidu. And, so there are like basically seven firms globally, four of them in the US, three in China, who are basically controlling almost 75% of data on humanity today. So, in certain sense, these are very, very powerful organizations because they have so much information about us. Uh, what blockchain does is it basically breaks that thing down, and it helps us, it basically empowers us back again. So this is my data. I own this data. I use this data to get me personalization. But at the same time, my privacy is preserved. So there is a concept called privacy preserving personalization. So you don't have to give away your privacy to get personalized information. And that is what blockchain does. And two, if somebody wants to use data on you, they basically pay you. So this whole model, like where Google uses our data to serve us ads, but we don't get anything from that, right? So what if my data is to be used to send me personalized ads, but that is based on my consent? So if I give consent that yes, Google, I allow you to use my data, and therefore you can serve me personalized ads, but for that, when I give it my consent and then you earn certain revenue from that ad, I want a share of that, right? So this whole model where you get that power back, you are more empowered. I think these are the models which are actually getting evolved as we speak. So there is a certain amount of sophistication already out there, and people are working towards making it more seamless. So this is a very beautiful concept of privacy preserving personalization and democratization of AI. And that is all possible by bringing the two powerful technological tools together, right? Uh, then I think we get into a lot of interesting areas and use cases, and I'll be happily talking about all of these when we do the workshop. Again, I mean, this is a very interesting area. So imagine today you're running a clinical trial and you have a certain catchment area. So you are in Boston, you're running a clinical trial, and your catchment area is all those people who can contribute and come on a regular basis, and you can always measure what's changing in their health basis what you're administrating them. Now if you are away from that catchment area in Boston, imagine you are in London, or you are, I don't know, in San Francisco or somewhere else, it's very difficult for you to participate in that. Like what bringing blockchain and the information on AI on healthcare does is you can basically contribute your information to that same clinical trial pool, because obviously your identity first gets verified and you give consent to share your information, but that information is stripped of your personally identifiable sort of attributes. So if you do not want to be identified, you can still contribute to that data pool, but without getting identified, right? And of course, you can get paid for it. So the process of getting solid clinical research done with more subjects and in perhaps a faster time frame is possible when you bring these things together, because now information can be taken from all over, because the patient's identity, at least the verification part has been done, and then they're giving consent to share their information, and they're doing it because obviously they get paid, right? So that's the idea here.
Yeah, okay. Anurag, we can just take one more minute. So we have next speaker.
Okay. um,
And all attendees, you can post your questions in the chat window or Q&A. Yeah, go ahead.
yep. And then let me see what else is there. These are some of the areas where blockchain and AI are coming together. Let me see if there's any interesting thing to talk about. Otherwise, I think I'm going to stop here, because this is I mean, if I start getting into this, it's going to take a lot of time. Yeah, okay. So yeah, this is, again, we will talk more about who wants to come into this area and what kind of skills they require, etc., right? So I hope you got a fair idea of what this is going to look like when you join in. Obviously, we will take a deep dive at various levels in terms of the technical nuts and bolts, and for those of you who might be interested in looking at the coding side of things, I'm happy to touch base on that. But given the diverse audience, I think I'm going to make sure that it is appealing to everybody. That being said, I think I'm going to stop here.
Yeah, we have one question, Anurag. So do you want me to read it?
Yes, please. Yeah.
Is there any open source framework to use cell phones as distributed compute?
So that's a very interesting question. So particularly if there is a protocol, I need to check. But in terms of frameworks, there are definitely a number of them where Samsung and if I'm not wrong, the latest Apple iPhones also have the blockchain computing chips in there. So what that means is now, and I will check and let you know which models, where they enable your smartphone to actually, as I was telling you, generate this personalized data for you on the local device level, and then give you that control, right? So there is definitely those chips which I think and they've been in the market for a good 1.5 2 years now. So I can let you know which ones or which models support that, and feel free to explore.
That's a great talk, by the way. I've been very interested in the blockchain stuff for the last probably, I don't know, 8 years or something, and I still haven't gotten around to like diving too deep there. So very interested in that content. Okay, let me share my screen now. Okay, can you see my screen, Lena?
Yeah, able to see. Go ahead.
Can you still see, even after PowerPoint?
Yes.
All right, so really this workshop, I think the title includes Kubeflow and GPUs and BERT and things like that. We've kind of renamed it to Data Science on AWS. So this is, I'll be doing most of the speaking for the workshop. I'll have the co-creator, Antje, out of Germany. She'll be being a like TA and possible co-presenter. We'll figure that out between now and then next week. But we've been doing this workshop for over a year, but actually this is brand new material, and you'll be some of the first people to see this brand new material. And all of the material is based on this book that we have written. That'll be out in April. So April 7th, we're doing the final revisions and, final acknowledgements, all that stuff now. Very exciting. Great partnership with the folks at the O'Reilly Media. And it's 12 chapters, 500 pages, hundreds of code samples. We sort of lost count at some point. All of the code is in this GitHub repo, Data Science on AWS, separated by hyphens. And we also do monthly webinars as well too. So if you go to that link, you can find our like meetup page that's named the same as Data Science on AWS. The cool thing is we had reInvent. So me and Antje both work for the Amazon Web Services, and every year around December, just after Thanksgiving, I believe it is, there's a huge conference. So obviously this year, this past like December, the conference was fully online, and there were 250 releases just within AI and then ML. And that's compared to, I think 40, so 40 releases for like containers, for example. So we're seeing lots and lots of like innovation coming out of AWS specific to data science, AI, ML. And so we spent the entire Christmas and, New Year's and all of January getting all this content into the book and into this new version of the workshop. So by the end of this, we'll actually be focused on the new SageMaker pipeline. So while we will show Kubeflow, we will like mainly focus on SageMaker pipelines, which are super easy to use. We have notebooks that go through all the steps. We explain everything from data ingestion to data transformation, feature engineering, to model training, to model tuning, and then deploying these models. And then we can then test these models, obviously, and then start all over again and then make this a continuous pipeline. And so really, the way that the workflow is structured, if you pull up the, let me pull up the actual GitHub repo here. Just this will make a little bit more sense. This is what we'll be working off of. This is a public repo we've had for quite a while. We have about 1,300 GitHub stars, 476 forks, which I'm super proud of. That means people are, really using this thing. We'll be focused on this quick start. So last year we actually had a, quite a painful 8 to 12 hour workshop as we were writing the book that went through 01 through 012, and these map to the chapters of the book. And we realized that people were either falling asleep or they couldn't. Because we would start this at like 8 in the morning and go straight through with maybe 30 minutes of break, and that was pretty painful for pretty much all of us involved, including me and Ansha. So we've actually come up with this streamlined version that, really focuses on pipelines and sort of, so we set up the environments. We'll actually get data into S3. We'll be training a BERT model. So still using BERT. And the data set is the customer reviews data set. So this is Amazon customer reviews data set from 1995 till 2015. So here's the actual data set. Pop that open. So this is public data set, 20 years of Amazon customer reviews, which is very interesting from a natural language processing standpoint. So we've decided to focus on BERT. I think there's 150 million reviews in here. So we'll only train on a subset because we don't have a whole lot of time, but that's what we're going to work with. And we'll also, create and set up and do queries with the Athena, which is based on, that's based on Presto. So this is Amazon, the Athena. It's similar to Spark, Presto is similar to Spark in concept, but is much, much faster for sort of ad hoc analytics. And Presto is a very popular open source, and so think of this kind of like managed Presto. And then we will visualize the data set. We will actually analyze the data set for bias. Now, this isn't the traditional, male, female gender bias or race bias. This data set doesn't have that information, but we will look for imbalances in the number of reviews we have for different product categories. And so this is natural because throughout Amazon, back in like 1995, they were only selling books. So let me actually pull up one of these visualizations. And then throughout the years, they were starting to then add more and more product categories. They did ebooks, they did computer software, they did video games, they have Prime Video. And so, sorry for the scroll here. We'll be looking at the average ratings and see if there's any, so here we can actually see right away, gift cards on average have a higher rating. So this product category has a bit of an imbalance relative to this rating. And what we're going to do is actually build a text classifier with BERT that can take in sort of comments in the wild, let's say Twitter or Facebook messages talking about Amazon products. We can then predict the star rating 1 through 5. So 1 is bad, 5 is good. And so that's what this data set has. It has 150 million textual reviews with the actual star rating that the user gave. And so that's a good indication of this review, this set of words, of tokens, of terms will typically lead to this star rating 1 through 5. And so we'll actually look at sort of bias as kind of a negative term, but really this is an imbalance. And then we will take action and actually downsample, maybe down to the smallest category here, which appears to be digital software, has the lowest number, or actually has the lowest average rating. I think number of reviews is another chart here. This is the actual number of reviews. So here we see books actually has way more reviews. And that's because books have been around longer, right, on the Amazon.com product catalog. And we see personal care appliances coming in last. Now, there's been more product categories added. This particular data set ends in 2015, but this is 20 years. And so we will actually take a look at sort of all of these. We will use the new bias detection from SageMaker called SageMaker Clarify. And we'll run through that. We will also focus on scaling machine learning. So typically, if you're doing ad hoc analytics or small, if you're training models on small data sets, yeah, so that's typically okay just to do on your laptop or on one single server. When you get to these 150 million reviews and terabytes of data, yes, that's just not possible. Not on your laptop, certainly not on like your laptop, but and typically not even on a single instance or server. So you need to then scale this out to do multiple servers. So we'll show you how to do that and how to scale out machine learning. Some of you might not need to do this. This is a common question we get is, why would I want to make my stuff more complicated and like use a cluster when I can do this on the laptop? And yeah, so those people typically are not using large data sets, and there's really not much more we can do there. So this is really for people who anticipate large data, yeah, the like classic term big data, or have large data already, or are just curious and just want to see how things are done at scale. Okay, and we'll then create the SageMaker pipeline with BERT and show you kind of a fun little teaser image here. Let's see, GitHub. Come on, GitHub. Yeah, there's quite a lot of images in these notebooks here. Yeah, so we will actually create this pipeline. I have a flashier version of this that's actually generated by SageMaker Pipelines and SageMaker Studio, which we will use for the whole workshop. But we'll be doing feature engineering. This is where we convert raw text, so the actual raw reviews into BERT vectors, right? The embeddings that BERT will use to then train the model. We'll then actually take a look and sort of analyze this model to see how did the accuracy do on this latest training run. If it's better than the previous model, then we will continue on and then deploy it, and then potentially do an A/B test or multi-arm bandit test, something like that. So we will actually run through all these steps, and then we will do the evaluation. We'll then register the model and then deploy it and then test it. So all the code is all in here. Yeah, like I said, this is really kind of the most popular thread through this sort of 12-hour like workshop that like we were doing last year. So we've greatly simplified it. If you do want to dive deeper into different like pipeline options, for example, here's how to do the same pipeline with Kubeflow. And we have all the steps here to set up Kubeflow. You could do it with, if you're already using Amazon Step Functions, some of the early adopters of Step Functions, we show how to build the same pipeline with BERT using Step Functions. There's a TFX version. This is Google's TFX project, the like TensorFlow TFX. We also show, what was the other one? We have human in the loop here as well too. So this is actually using augmented AI. I have a screenshot of this here in a bit, but where you can have humans actually become part of the pipeline and sort of, right, like eyeball the certain predictions to see how they're doing, or if we are not confident with certain predictions, in real time, we can send these predictions off to the augmented AI and then have humans make the prediction and then override, not in like real time, but then put that like newly overridden prediction into a queue to then be trained on. And then of course, Airflow. Everyone loves Airflow. So at reInvent, they actually launched, so Amazon actually launched what's called the Amazon Managed Airflow, Managed Workflow for the Apache Airflow. MWAA is the official term. And this is how you would actually set up the Airflow stuff and kick off and do the exact same BERT pipeline with Airflow. So now again, like we won't have time to do all this because of the window of time for this workshop, but all of this code lives here. This is all actually documented in the book in much, much greater detail, but this is a nice hands-on way to do this. Oh, and then I should also mention, you don't need to have your own AWS account. We will actually give you a temporary like account for the day. So no cost to you. This is all, I work for the marketing team. I'm in technical marketing. So this is one of my favorite parts, is actually being able to to like give you these instances or these clusters for free. So by the end of this workshop, you'll be able to actually ingest the data from the like public data set into your S3 bucket. You'll then run queries and like do analysis. You'll prepare data and convert to the BERT vectors. We'll then train with TensorFlow. We do have PyTorch version as well. I can point that to you the day of the workshop. It's in the code base. We can also deploy the model as a REST endpoint. That'll be the last part of the SageMaker pipeline. And then just kind of show how all of this stuff comes together. So this is really what I've already said a couple times. So this is the sort of quick start is the term that we used when we built this faster thread through the whole workshop. So we will ingest, explore, and then go straight to the pipelines, which does prepare, train, evaluate, register, and then deploy. This I had mentioned verbally earlier, showed you where this code lives within the repo. So we'll actually be building the SageMaker pipeline. There's all those steps: processing, training, evaluation, and then register, create. Here's what this is the Kubeflow version. So processing, training, create, deploy. This is the like Airflow version. So this is with managed Airflow, which is a new service offered by AWS. And here's the step functions. This is the exact same workflow. Here's the human in the loop. For this one, we actually would build upon the Amazon Comprehend service, which can do sort of sentiment analysis straight out of the box without any model training. It will learn your, so it will still learn your specific data set, but like Comprehend does come pre-trained on millions and millions of documents and has a really good notion of sentiment. And we actually train it in the workshop in the full 12-hour version. We actually train with Comprehend on our specific data set to then predict star rating and have like really good results with that as well. And then there's a service called Augmented AI. And this is what I was saying, for low confident predictions, we can have humans. And so this builds upon Mechanical Turk, or you can create your own private workforces, they're called. If you want to have, start off with the data science team that could be doing this sort of manual relabeling of these low confident predictions. These end up as new training data. And then on the next run of the pipeline, we can improve the model on some of those outliers. The other big release from like AWS was this thing called SageMaker Projects, which is really, it's kind of a goofy name, but it's a way to, in an ML ops or sort of GitOps way, you can automate your pipeline. So either new data gets, or if like new data gets pushed to like S3, we can then launch a new pipeline. Same SageMaker pipeline that we saw before. You can also, if you wanted to trigger Kubeflow pipelines, if you want to trigger Airflow pipelines, all that's done with the same mechanism. This service called the Event Bridge that has triggers between S3 and then all the services. But yeah, back to the SageMaker projects. This is really sort of the like ML ops story for SageMaker pipelines. And you can, if you even commit code like your train.py file or a new feature engineering script that like you've devised because you found a better way to create the BERT vectors, or maybe want to try a different variant of BERTs, you can actually commit that code and then trigger the pipeline. So either data or code. Yes, code on the left and then data on the right. So this is the specific agenda. Really the first like half hour is just kind of welcome, setting up the environment, making sure you can get to the Amazon account. Like we give you the specific AWS account, and then start and build the environment. So that should take about 30 minutes, maybe 40 minutes. And then we start to actually look at the data and build some of those charts using Matplotlib, using SageMaker notebooks, using SageMaker Studio, which is really the single view into all of the SageMaker stuff. So we'll have a hands-on view of that. We'll then build and sort of define the pipeline. And then after the break, we will actually run through the pipeline and then talk through all of the steps that are happening. We'll then end up with a deployed model, and then we can test that model. This is a TensorFlow model using TensorFlow 2x. And then Keras as well too. Yeah, so Keras is an API within TensorFlow 2.x. So that's it. Thank you much. You will meet Antje next week. She's in Germany, so it's starting to become her like evening time right now, but she will certainly be on late her time zone for this event next week. Yeah, Selena, any questions?
Yeah, we have one question. So do you want me to read it out, or you can see
Sure.
it? Yeah, we have a question from Govind. So does this or do these pipelines provide access to all the public and Amazon specific data?
Is the question, are they only, so the workshop, we have chosen to use a public data set, but no, you can certainly use like any data set you want. And in fact, the first step here, which is ingest, or if I go back to this first step here, we're actually taking the like public data set, and copying it into your like Amazon account. So we take public data and then make it private and then operate on the private data. So it's just a nice convenient data set that we've used in the past for like some of our research projects and things like that within Amazon. So yeah, did that answer?
Okay. Yeah, no more questions. We'll just wait for a few more minutes. So anybody have questions, you can post in chat window or Q&A window. If Chris, you can take a couple of minutes if you want to explain anything.
Let's see. So the recording will be shared. Yeah, let me look at the chat. Okay. Just put this side by side with the GitHub repo. Yes, it's a fun workshop. If you want to see old videos, or not old videos, but recent videos, we do have a YouTube channel that's available at that same link as well. But yeah, super excited to participate in this event. There's a lot of good workshops and